Gentlemen, bonjour. Today we will talk about binary trees. And this is one of my data structure videos. If you're interested in more, please watch them all on my channel. Thank you so much. Bye. Just kidding. We're just getting started here. So let's start with the rules that make up a binary tree. First rule is that when we insert data, anything that is smaller or equal to the parent node should go to the left side. And anything that is greater should go to the right side. Pretty simple, right? And then the maximum amount of children is 2. So you cannot have, for example, a structure like this, because then it becomes more of a graph than a tree, right? So now we'll implement this stuff, but before we do that, I would like to show you visually how this works, how insertion works, and how printing the tree works, because when you print it, the algorithm does it so that it's in order. So the data points inside are sorted, so it would print like this. Okay, now I want you to take a look at this website. If you want to go there, it's free and I recommend it if you want to visualize a binary tree for yourself. So let's just start adding some values. 10. Now 15 should go to the right of 10 because it's greater. And if I do, for example, 7, it should go to the left. Okay, and now if I go 16, can you guess where it's going to go? Bravo! Bravo, you guessed correctly. I'm so happy for you. Okay, now 3 should go here, right? Because it's smaller. And if I do 8, where do you think it will go? I think it will go here. So I hope you understand by now how this all works. Now we can go to code it. Please remember that if you are programming in a different language, this is also relevant to you because the implementation of data structures across different languages is really similar. Let's start by defining the node class, the constructor. We want to have self, data, and also I want to initialize the left side to none by default, and the same thing for the right side. And also data should be just data. So now we want to have a function to insert stuff into our new great binary tree. And first let's check if self data actually exists, because if it doesn't, we should just fill the empty space, right? So the root node. Okay, and now I want to have the greater or smaller logic. So if data is greater or equal to self.data, and if that is the case, I want to check if I should create a new node or if I should do a recursion. So if self right is none, in this case I want to create a new node because it's empty. Right, and else I want to repeat the process. I call the insert function. Okay, and that should be correct. Okay, and now I want to do the same thing but for the left side. Okay, but I need to change this. Okay, left, left, left. Okay, let me clear this. Now it would be nice to have a display function. We just need self for that. And here I want to also use a little bit of recursion. So if self left exists, then I want to recheck it. Okay, and the same thing for the right side. And in between that, I want to print self.data. Okay, now I think let's check if we have any syntax errors. No, okay, thank you. Now we can try to create a tree to test if everything is working correctly. So I create a node with, let's say, 10 as the root. And next I insert some values. So let's insert 1, 2, 12, 14. Okay, that should be okay. And at the end I want to display it, so tree display yeah, of course I display, yeah, okay, and it works. It's in order, it's sorted. So that was a quick example of how you can do it in Python. So this is basically how a binary tree works. Let me know if this video was interesting to you. And let me know also if you subscribe to my channel by leaving a comment. That's interesting information for me. Leave a like if you liked the video. And thank you so much. Gentlemen, au revoir.